So this chapter is all about what we call the mole. So we're going to begin today just by going over some simple concepts about how we can find information in relationship of elements to the mole. So all the mole is a quantitative, and anything that is quantitative means it's based on a number. So it's a number that has been measured. So it's a numerical value. And that is what we call our counting unit. So they came up with the mole in order to that is consistent from element A to element B, so that when we're comparing element, let's say magnesium to oxygen, we're not comparing apples to oranges, we're comparing a constant unit. So they started with the element of carbon, and what they determined is that 1 mole of carbon is 12 grams, and they set that as our comparative unit. Very similar to how there are always 12 in a dozen. Okay, so it's just a unit. So they started with carbon, and then they counted how many molecules were in 12 grams, and that was their base unit. And from there, they did the same number of molecules for magnesium, for oxygen, and then came up with a mass so that we have a comparative value of each element in relationship to one another. So when we're looking at the mole, again, they started with 12 grams of carbon. And like stated before, they figured out how many atoms of carbon were in that 12 grams that they measured. So they determined that there were 6.022 times 10 to the 23rd atoms. You need to know this number. This can also be used as terms of particles. You can see it as terms of molecules. So just know that there's different variations. Atoms, particles, molecules all mean the same thing. So again, they took 12 grams, that was their base unit, and then they counted how many molecules. They figured out there were 6.022 times 10 to the 23rd atoms, and that is the number of atoms they use for all molecules on the periodic table. That is called our molar mass. The unit for molar mass are grams per mole. So since there are many isotopes, so hopefully you remember that from first quarter, isotopes are the same atom with different number of neutrons. So since there's not just carbon 12 or carbon 13 or carbon 14, we have this decimal number. And that number is called our molar mass, or average atomic mass unit. So we learned how to calculate that in the beginning of the year. That number we're going to interchange with molar mass and atomic mass unit. This is where we are going to look our periodic table to get our molar masses, or our average atomic mass number. So for example, if I were to ask you to find it for lithium, you would say lithium has a molar mass of 6.941 grams per mole. So in 1 mole, which remember is the 6.022 times 10 to the 23rd molecules, there would be 6.941 grams. Where in comparison, if we were to look at chromium, there would be 51.996 grams per mole. So the same number of molecules, both of these being 6.022 times 10 to the 23rd molecules, we can see that chromium is a much more dense molecule. There are a lot more protons and neutrons in this molecule, so it is a lot heavier. Okay, so that is, again, where we're going to find our average atomic mass. And again, these numbers are all decimals because there are isotopes with different percent abundances. So we are going to, again, you need to know Avogadro's number. That is our 6.022 times 10 to the 23rd. Okay, again, that's just called Avogadro's number. That's called particles. Atoms, molecules, all the same thing. That is what they use. So they counted that many atoms, weighed it, and that's where we got our molar mass, grams per mole. So again, the molar mass, grams per mole. So number of grams in 1 mole. So everything is set equal to 1 mole, which is 6.022 times 10 to the 23rd. We find the molar mass by looking at the periodic table. So it says find the molar mass of iron. So we're going to go to our periodic table. We're going to find iron. And there we have it, 55.845. We are going to round to 2 decimal places. So we are going to say 55.85 grams per mole. All right, so then we're going to find the molar mass of zinc. So we're going to go on our periodic table, and we're going to find it for zinc. So 65.39. We're going to round to 2 decimal places, so that one's already rounded. And that is our final answer of zinc. So now let's say we have a compound. So this makes it a little different. So we have water, and in water we have hydrogen and we have oxygen. So we know in our molecule we're going to also have 2 hydrogens. So we're going to go to our periodic table. We're going to find hydrogen. All right, that's 1.0079. That gets rounded to 1.01. So we're going to do 1.01 grams per mole. However, we have 2 of them. So that means we need to multiply this by 2. We get 2.02 grams per mole of hydrogen, but in that same compound we have oxygen, so we need to find oxygen. Okay, that's 15.999, but 2 decimals, we're always just going to go the hundredths place, 16 grams per mole. So we are now going to do 16.00 grams per mole. But we don't necessarily care about each individual part, we care about the molecule as a whole. So to figure out what the entire water molecule weighs, we need to add the molar mass of hydrogen in the compound plus the molar mass of oxygen. There's only 1 oxygen, so we just multiply it by 1. So we do 2.02 plus 16, so 18.02 grams per mole. And that would be our final answer. Okay, I want you guys to try doing the magnesium nitrate as for your homework. Just remember that that 2 gets distributed to the N and the O. So that means that we really have 2 N's in this compound and we have 6 oxygens in the compound. So you need to multiply those numbers, the molar masses. And Mg, we only have 1 because that's outside of the parenthesis. Okay, so that's how many we have of each of the atoms. Now you need to figure out the molar mass in order to figure out the total compound. So do that for tomorrow and come in with any questions.